Hi everyone, welcome back to my YouTube channel. In this video, I have a very interesting solid geometry problem. So, let's say we have a cone of radius 1 and height 2. What is the maximum volume of cuboid inside this cone? So, pause the video a bit and see if you can solve this problem and watch to find out. So, firstly, let's try to create some variables. If we try to draw a cuboid, right over here, let's say that the length is equal to A, the width is B, and the height is equal to C. So the expression for the volume of this cuboid, the volume would be A times B times C. Let's say we want to create a diagram of the cone and the cuboid. We can create a graph like this. So this triangle is basically the cone if you look at it from the front view. So we can see that this point over here is basically the circle being pressed down and we look from the front of it. And then this rectangle is just one face of this cuboid because you only look at from one of its sides. And then we can label some of the values in here. We can say this is the length of the cuboid, A. We can say this is the height of the cube, C, and then this base of the triangle is basically 2 because the diameter of the cone is also 2, and then the height is equal to 2 also, right over here. So with this we can create an equation that correlates A and C. So how do we do this? Let's take a look at this triangle. That triangle would be similar to the larger triangle. The ratio of its sides would be the same. So let's say the ratio of the base of the smaller triangle, this one, is equal to A. And then the larger triangle has a base of 2. So the ratio of those two sides is A over 2. And then let's see, what is the height of this smaller triangle? Well, that will be the height of the larger triangle minus by the height of this rectangle. So that is 2 minus C. And then the height of this larger triangle itself is equal to 2. So now we have an equation that correlates A and C. We can simplify it. A equals 2 minus C. And now we can take this and substitute into the original function. So the volume would be equal to A equals 2 minus C. So rather than writing A, we can write 2 minus C and then multiply it by B times by C. So now we have a more simplified version of this function. However, what about for B? Can we substitute that function? Well, let's take a look at this original diagram. You can have the cone being represented as a triangle and then the rectangle for the cuboid. In the first diagram, we represent the base of the cuboid as A, but it can also work if you write it as B over here. This becomes B, and with the height as C, the height of the triangle as 2, and the base of the triangle as 2. We can also create the same exact function as this one, but instead we use B. So we can say the ratio between this length and this length, that is B over 2, that's equal to the ratio between this height to this height, which is 2 minus C over 2. And then in the ending, we got the exact same expression. B equals 2 minus C. And now we can input it back to the function. So now the volume equals 2 minus C multiplied by 2 minus C times by C. So far, we have simplified the function for the volume into this expression. And what we can do is optimize this function using derivatives and find its maximum value. So now we have the function for the volume, which is equal to 2 minus C times by 2 minus C squared multiplied by C. And now we can optimize this function and find its maximum value. So firstly, let's simplify this a bit. So volume is equal to 2 minus C times by 2 minus c times by c. That's equal to 2 times 2, that's 4. 2 times negative c minus 2c. Negative c times 2 minus 2c. Negative c times negative c plus c squared. Then multiply that by c. So now we have volume equaling 4 minus 2c minus 2c. That is 4 minus 4c plus c squared multiplied by c. We get 4c minus 4c squared plus c to the third. So now, to optimize it, let's find the derivative of this function. So, d over dc, the derivative of 4c minus by 4c squared plus c to the third is equal to, using the power rule, we get 4 minus by 8c plus by 3c squared. So now, to find its critical point, we set this derivative to equal 0, and then we solve for it. So now, we get that this expression, which can be simplified into 3c squared minus by 8c plus 4 equal 0, and then we can use the quadratic formula for this. C is equal to 8 plus or minus square root of 64 minus 4 times by 3 times by 4 divide by 2 times by 3. And then, after simplifying this expression, we get that c is equal to, or c is equal to 2/3. So it's either 2 or 2/3. However, let's take a look at this. We're talking about a cuboid inside a cone. The cone has a height of 2. So the height of the cuboid itself has to be smaller than 2. Because if it is exactly 2, then the cube will have no width, because it's exactly one line that hits the height of the cone. So actually, c must be 2/3. And then, if we input it back to our original function, the volume is equal to 2 minus by 2/3 squared times by 2/3. This expression would be 32 over 27, or approximately 1.185. So there you go. That is the absolute maximum volume for this cuboid. And there's a little bit of challenge for you. What if you were to try this problem, but rather than using a cuboid, we use a cylinder? So that's an interesting challenge for you. So that's it for this video. I hope you enjoyed. Make sure to subscribe and don't forget to like the video.